Hello everyone, welcome to our group presentation. So for our semester 2 for Computer Organization and Architecture course, our group project was to conduct a CPU and hardware performance benchmarking. We are excited to share the results of our research and analysis with you today. So over the next few minutes, we will be exploring CPU benchmarking that we did for our project. So our team consisting of myself, Uday Darshni Anak Perempuan Prakash, Radin Salma Humaira binti Muhammad Munim, and also Siti Nurul Amira binti Sheikh Sulaiman. All of us has worked diligently to bring comprehensive insights and data-backed conclusions. We aim to provide a thorough understanding of CPU benchmarking. So let's explore the CPU world together and let's get started.
So this part for the introduction. So what is benchmarking? Benchmarking is the method where we measure and assess the performance of the software and the hardware running specific tasks. And then there is two type of the benchmark, which is synthetic and then the real world. And then the tool that we use, which are the CPU Z, Geekbench, and the task manager. And then we do the tested on the 3 laptop. The problem background, the issue is we lack of the understanding of the laptop performance and its component. And then the solution is we use the benchmark tool, which is CPU Z, Geekbench, and the task manager. After that, we develop assembly code to measure performance. So our aim are to gain the deeper insight why the benchmark is an important tool to describe the performance of the different laptops due to the component like CPU and the computer memory. Our objective for this project is we want to able to understand the principle of the CPU benchmarking. We want to compare the performance of the different CPU and GPU on the different laptops. Also, we want to analyze the impact of the different workloads on the CPU performance, and we want to learn to use the benchmarking tools and interpret their results. So our focus to measure and compare the CPU performance through the computational task. There is two type of the benchmarking type, which is the synthetic benchmarking and then the real world benchmarking. So the synthetic benchmarking, we use the simulation for the task like 3D rendering or the file compression. So real world benchmarking, we want to measure the performance through the specific application. So we use three tools, which are the CPU Z, task manager, Geekbench. So there is a function and then the step how to download these tools. So this is the result after we do the benchmarking on the 3 laptop. So from the result, we can see that the best performance is the HP Laptop 50 and the low performance is the Lenovo Yoga F50.
Now we're going to look at the comparison of the CPUs. So we have only three CPU, which is the AMD Ryzen 5 625U, the Intel Core TM i5 1325U, and also AMD Ryzen 5 7525H. So we can see at the graph that the high score belongs to the Intel Core, while the lowest score belongs to the AMD Ryzen 5 5625U. So we can see that having higher CPU score means that the task performance can be done faster and the execution is better. So while having low score doesn't necessarily mean it's bad, but it's just it just have a big disadvantage there to do a quick process. So by looking at the comparison graph, we can observe the difference in average between the three CPUs tested with synthetic benchmarking. Having a higher CPU score means that the task performance execution is better. We can see that the Intel Core TM i5 10335U has a high score compared to AMD Ryzen 5. The two AMD Ryzen in terms of CPU single thread, single core, and also CPU multi-thread, multi-core. So having higher score means that you can have you can do gaming and you can also do rendering. But most focused on gaming is that we focus on the single thread and the single core, while for rendering video we need a lot of cores, so the multi-thread must be focused on. But since we see that the Intel Core excel in both of these terms, so this CPU is good for both of the stated activity, the gaming and also the rendering task. Now we can look at the comparison in Geekbench. So we compare the single core score and also the multi-core score between the CPUs. So in Geekbench, we tested the CPU using the stress test. So it takes a long time, and once we get the reports, we can see that the score is such like this. You can see that at maximum load, the stress test will try to use the full capacity of the CPU, which in the long term can lead to the fact that other processes will perform more slowly, and some will even hang. It is considered as the total chamber of CPU because of its prolonged duration of testing. So some of the simulation tested are stated in the reports, which are file compression, navigation, HTML5 browser, PDF rendered, photo library, client, text processing, asset compression, object detection, background blur, horizon detection, object mover, HDR, photo filter, ray tracker, and structure from motion. So there are lots of simulation, and that's why it takes a long time. So we can also conclude that the highest score belongs to the Intel Core TM. So next we're going to move to the Windows Task Manager. So we can see that we are comparing it based on the load that have been categorized into three, which is the low, middle, and also heavy. So we can see here, average of the best CPU performance belongs still to Intel Core TM. So next we're going to move to the Windows Task Manager. So we can see that we are comparing it based on the load that have been categorized into three, which is the low, middle, and also heavy. The average of the best CPU performance belongs still to Intel Core. When we're doing the low load activity by opening Microsoft Word or any other text processor, the range falls a little bit higher from the theory. The theory mentions that it's supposed to be falls in the range of 30 until 50%, but we received from 42 until 67%. So we can deduce that some of the background processes and inefficient resource management were unable to be terminated. So for middle load, we opt to use Google Chrome tabs and stream video to increase the memory capacity, the memory storage. usage. So our observed result is that it falls in 50% and 71% range. Theoretically, it was supposed to end until 60% at the higher end. So we can see that the CPU usage can spike, potentially due to the additional task running concurrently or increased demand from the active processes. So lastly, the heavy load, we opt to use to run SMD code and also gaming. So we also do rendering video, and the observed result is that it falls in the range of 69 until 90%, while the theory says it is supposed to be above 70%. So we can say that under heavy workloads, the CPU might indicate variability in task execution or temporary lulls in processing demand. And so lastly, compare CPU by using the benchmark program. So we compare with our two CPUs, so which is the AMD Ryzen, both of them. So we can see that AMD Ryzen 5 7535H has lower score compared to the AMD Ryzen 5 5625U. So this is the difference. We compare the CPUs based on their difference, not by their millisecond before and after. So this difference is important because we can see that from the 7535H, the difference is lower compared to the 5625U. That means the millisecond before and after does not have a big gap between them. So that means the CPU is is optimally running. Okay. So lastly, we're going to look at the benchmark program, which we use the difference from the CPUs during the benchmarking program from the two CPUs. So we can see the AMD Ryzen 5 7535H has lower score in average compared to the AMD Ryzen 5 5625U. So this is because difference is used to see the how much of a difference between the millisecond before and after. So that means if the gap between the before and after is lower, that means the CPU is performing better. So in this case, AMD Ryzen 5 7535H is still running consistently, and also AMD Ryzen 5 5625U is still having the lower score compared to the other CPUs.
In conclusion, we analyzed the AMD Ryzen 5 5625U, Intel Core i5-1235U, and AMD Ryzen 5 7535H CPUs, highlighting their strengths and weaknesses in various tasks. So throughout this process, we sharpened our skills in data analysis, interpreting benchmarking results, and effectively presenting technical information to diverse audiences. And lastly, the challenges we faced was navigating the complexities of benchmarking tools. Other than that, we also faced inconsistent data outcomes, which required us to refine our testing methods to ensure we have accurate conclusions. This benchmarking project was a great learning experience that allowed me to apply what I learned in class to real-world scenarios. Using tools like CPU-Z, Geekbench, and Windows Task Manager gave me practical experience in measuring CPU performance. I saw firsthand how different processors perform under various conditions. Moreover, collecting and analyzing data from different CPUs helped me to develop my analytical skills. I learned how to identify patterns and draw conclusions about CPU performance. I also faced and overcame challenges as it is my first time using benchmarking tools. I was confused at first on where to begin, but with the help of my lecturer, Dr. Nur Haliza, my teammates, as well as Dr. Fuad's video explanation on how to conduct this project, I was able to improve my problem-solving skills. This project really helped me to understand more about my laptop, and I would definitely say that it was a valuable part of my learning experience in this course.
Measure its performance, we can do benchmarking. So basically, I learned how to measure performance on laptops by benchmarking and also become a wiser user in choosing my CPU and computer specs in general in the future. And I think that benchmarking is a good knowledge to be widespread to help reducing the digital illiteracy among the common people, less to being getting scammed and also being fooled by the marketers selling the good points of the laptops in hype right now. So I think that by having this knowledge, you can assess the best laptops for these people to use according to their needs. So if let's say that they want a better gaming laptop, then I say that they need both CPU and GPU with the with the good brand on it. Like I say, the AMD Radeon is kind of good. Also, I say that I feel more motivated in truly understanding several benchmarking methods and score reports during many possible workload stage simulations. I feel like these benchmarking methods really try its best to conclude a good score to an extent. Basically, because without this relative average score, we cannot compare the CPU with the other CPU. Let's say if we just compare the CPU score of rendering a video and compare with other CPU, it cannot have concluded the overall performance of the CPU, and so it will become unfair. And I feel like it is a good alternative for us to know benchmarking widely. And lastly, it is a precious learning experience because despite facing technical difficulties and also time constraints, I feel like this is really opening my eyes really wide, and I see that we are supposed to know our laptops and our CPUs better.
So this is my reflection from this project. So there's from this project I have learned a lot of things. The one of the thing is when I have an issue when do the benchmarking on my laptop. So one of the issue is the power saving can reduce CPU GPU power and affecting my benchmarking result. So the solution, I set the power management setting to high performance during the benchmarking. And also from this project, I also enjoy doing this project because I learn more about my laptop's performance. So it's very a valuable experience to see how the different settings and condition impact my device's performance. And also the last thing is working with my teammates. From the teamwork, we share the knowledge and help each other with the problem. We also learn to use the benchmarking tools together. And also the last thing, we enhance the project enjoyment and improve the quality of the results.
So, Assalamualaikum and hi, Doctor. Today, in this video, we are going to present the demo of our usage and using the benchmarking freeware tools. So, my group consists of Radin Salma Humaira, myself, Siti Nurul Amira, and also Utaya Darshini. So, we only have 3 members, and so we are only going to use 3 freewares, which are the CPU Z, the Geekbench, and also the Windows Task Manager. So, now we're going to look at the CPU Z. Once you have opened up the CPU Z, we're going to look at this dashboard. So we can see at the processor's detail, it shows the name of the processor. Mine is AMD Ryzen 5625U. The codename is Zen, and so on. There's the core speed, and there's also the cache. We can see the level 1 data, level 1 inst, level 1, level 2, and level 3. So if you want to look at the detailed reports, we can save the report as text, and we can look at it in the folder. My laptop is really currently running slow, so I have to bear with it. Yeah, it's already there, but just in case, I just wanted to show for other people's reference if this video is going to be used some way. So my device name is Poppy, so we're going to look for Poppy. Okay, so there's Poppy. Now we're going to look at the report generated by the CPU Z. So this is the report. As you can see, the important details are where you see the circuit one. Let me redirect back. Oops. So this is the details. You can see number of cores, number of threads, the manufacturer, code name, the technology, the base frequency, and the data cache. So the level 1 instruction cache. It is actually that. The core speed is 547.5 megahertz, and the multiplier bus speed is 4.5 times 99.5 megahertz. And now we can look further, and this one, it is what has been mentioned. The memory speed, graphics, the GPU is AMD Radeon graphics, and also the memory is 16 gigabytes. So the bench is where we can do the benchmarking. So if we click on the bench CPU, we have to wait until the stop button turns back into bench CPU. Okay, so we're going to pick a reference. So this processor is currently having this score because it's really heavy loaded right now. And so that's it for CPU Z. Now we're going to look at Geekbench. Geekbench. So for Geekbench, we're going to conduct a stress test on the CPU. So if you click on this, it is going to be conducting right away, but we have to wait because stress tests really takes a long time. It do a lot of simulation. So for it to be measured properly, we have to wait. Okay, so while we wait, we can open Task Manager. So my memory is currently in the range of heavy load. The memory is in the 80% because I open many applications, CapCut, WebEx, and especially with Geekbench. It contributes to the memory. So right now it's doing a heavy load until we finish the Geekbench stress test. We will do the middle load and also the low load. Okay, so we're going to look at the Windows Task Manager. So we see it's already in the heavy load performance because we open CapCut. And also we open Visual Studio. So now we're going to decrease it by killing Visual Studio. So it's already decreasing. And we're going to kill CapCut. That's my pace, I know. So now it falls on the low load very fast because we do not have any initiative to open Google Chrome first. So now we're going to restore. The reason of me opening video stream was that it was supposed to be for the middle load, but it does not really help. So after opening the Google Chrome, you can see that it's already in the middle load. So that means theoretically and also practically, we are aligned with the theory. And so this actually shows the efficiency mode. So yes, we can now close Windows Task Manager. And finally, we can see the report on the Geekbench. I hope my OBS is working. Okay. So now I can see that my score, single core score, is for 352, while the multi-core score is 1,278. And this is the normal score. I've done this many times and it was supposed to be like this. But I've tried once when I was rendering a video, and the single core score is around like 500, 557, 53, something like that. And also the multi-core is around the same value, like around 550. And I was rendering a video. So that means rendering video requires multi-core performance. So while rendering a video, it might lag, it might delay lots of things, but that's because it's working to its best. So in the Geekbench report, we can see that it is informing us of the system information, the OS, the model, the motherboard, and also the CPU information. We can see the name of our processor, the bus frequency, the cache, the code name, and so on. And the memory information, we can see our memory size is 14.80 gigabytes, and it has 2 channels. So this is the single core performance. We can see that the highest score falls to structure from motion. And for the multi-core performance, the horizon detection is higher, the highest one basically. So with that said, this is how stress test is conducted. Because of these simulations from these activity, we can see the best task that the CPU can be excelled at. So for my CPU, it is best excelled at graphics, graphics representation. But that's because it works with AMD Radeon graphics, I think. And so that's it for our benchmarking tool demonstration. I hope this will suffice, and thank you, Doctor, for watching.
So today I'm gonna do the demonstration for the code part. So I'm gonna briefly explain the code. So this, we start by defining the message, the string 1 and the string 11. So we define the string message to display to the user, and then we initialize the coefficient 1 until coefficient 4, which is we choose from our date birthday, and then we initialize the x equal to 1. So we define the coefficient to represent the polynomial equation. And then for the code part, we display the string 1, which is we display the welcome message. For the string 2, we display the equation part, and then the string 3, we display the coefficient string. The string 4, we want to prompt the user to for the number of loops, and then we read that, which is we want to read the user input, and then for the string 11, we display the progress message. String 5, we display the result header. String 6, we display the first capture in millisecond, and then we display the first capture in millisecond for the write that. And then we initialize while sum equal to 0, and then we set up the loop counter, and then we initialize x to 1. And then for the loop part, this is for the coefficient 1. So for the coefficient 1, we call delay, which is one call the delay with a coefficient 1 millisecond, and then must be at 3 times, because when compute x the power of 3, and coefficient 2 x power of 2, coefficient 3 x the power of 1, and then the coefficient 4, we just add the result into the y sum, and then we end the loop. So if the CL equals 0, so it will end the loop. And then at the same thing, we want to display the string 7. And then for this part, the sub EAS capture millisecond first, we want to calculate the elapsed time, and then we store the elapsed time. We display and string 8, we display the execution time different level, and then we log the elapsed time for um, the first capture millisecond. And then the string 9, we display the polynomial sum label, and then we log the sum of the polynomial, which is y, sum of the polynomial result. And then we display the sum of the polynomial result. And then for the string 10, we display the continue prompt. So we read the user response, which is if the user enter y, so it will restart the main procedure. So that's all. So I'm gonna start to run this code. So this is the output for our code. Display message welcome, and then it will prompt the user to enter the number of looping. So we will enter 15, and then it will display the result for the first capture execution, the second capture execution. So this is the different execution after we do the subtraction from the second to first capture, and then the value of the stress test, which is the polynomial. So if we want to continue the looping, we just press Y, and then we enter the other number of looping, and then it will display the result of first capture. And then for the second capture, the value of sum from the stress test. So this, I'm going to share our result. So this is our result after we key in the loop for two laptop, which is an AMD Ryzen 5, and then 7535H, and then for the AMD Ryzen 5 5625U. That's all from me. Thank you.